in example 1c, our logarithmic equation is the natural log of x plus 1 minus the natural log of x is equal to 2. Okay. Again, our goal is to have something that looks like a logarithm equal to a number. That's not quite what we have here. On the left side, we have a logarithm minus a logarithm equal to a number. We really want just one logarithm equal to a number, okay? So on the left side, you are subtracting two logarithms of the same base. They're both natural logarithms. And we know from section 6.5 that we can combine two logarithms of the same base if we are subtracting them, okay? So property 2 tells us that subtraction turns into division. So we're going to use this property to combine the two logarithms on the left side of the equation into one logarithm, okay? So let's go ahead and do that. All right, so this is going to become the natural log of, you're going to keep the same base. The first thing is going to become the numerator. So x plus 1 will be your numerator. The denominator will be x. Okay, order matters there, so make sure you get that correct. Okay, so this is how you combine the two logarithms into one according to that property. Okay, so that's what the left side becomes. We didn't do anything to the right side, so it is still 2. Okay, and so now we have what we want. We have a logarithm equal to a number. Okay, once you have a logarithm equal to a number, you can apply the arrow method on it. Okay, so take your base. Remember, the base of a natural log is e. So if you want to write it in, so then this is going to tell us that e squared is equal to this quantity, which is the fraction. Okay, so let's write this out. Okay, so we're going to get e squared is equal to x plus 1 over x. Okay, we need to solve this equation for x. Okay, it looks a little bit intimidating. At least the logarithm is gone, but we have a fraction now, and also you see this e squared quantity. Okay, remember, e is a number. It is approximately 2.71. We are not going to write this left side as its decimal approximation. We're just going to leave it as e squared. But this left side is just a number. Treat it like it's just a number because it is. Okay, so we need to solve for x. We need to get x by itself on one side. Okay, and then on the other side of the equation, we have no x's. Okay, so our goal now, since we're solving for x, to solve for x, we need to have x equals something, and on that right side, there can be no x's. Okay, again, it's a little challenging because we're dealing with a fraction here. Okay, so what we're going to do, and we kind of touched upon this when we did composition, and we worked with those fractions in section 6.1. If you want to eliminate the fraction here, what we're going to do is we're going to multiply by this denominator to get rid of the fraction. Okay, so let me go ahead for clarity here. I'm going to rewrite my equation. Okay, so what I'm going to do is I'm going to multiply this side by x. Okay, because then you'll have an x. Remember, this is really x over 1. Okay, then you'll have an x in the top and an x in the bottom. So x divided by x will be 1. They will cancel each other out. Okay, well, since I multiplied the right side by x, I need to multiply the left side by x. Whatever you do to one side, you have to do to the other. Okay, so what this is going to lead to is this. Okay, so we are going to get the left side will become x times e squared. Okay, on the right side, you have an x in the top and an x in the bottom. They're going to cancel and leave you with x plus 1. Okay, and so then what we're going to do, okay, and this again also extended into section 6.2 when we were doing inverses. You now are left with an x on both sides of the equation. Okay, so what we're going to do is put everything with an x on one side of the equation, and then put everything that doesn't have an x on the other side of the equation. Okay, so I'm going to go ahead and move this x over. Okay, so I'm going to get x times e squared minus x is equal to 1. Okay, So now everything on this side has an x. Everything on the right side does not. Okay. And the trick to doing these problems, okay, is factoring. This term contains an x, as does this one. So we're going to factor out an x. Okay. We're going to write what's left. That's e squared minus 1. Because remember, if you multiply it back out, you're going to get what you started with. This is going to be x times e squared minus x. Okay. That's got to equal 1. Okay. This quantity in parentheses is a number. Okay. You could actually see that from your calculator. E squared is just a number. So that means e squared minus 1 is just a number. Okay. If I have e squared minus 1, that is just a number. Okay. So the x here is being multiplied by just a number. Again, we're not going to write out the decimal expansion. We're going to leave it as e squared. Okay. So this is x times some number. To get x by itself, we're going to divide off that number. Okay. And then these guys will cancel. And so x is equal to 1 over e squared minus 1. That's the answer. Okay. So you have solved for x. You've got x equals, and on the right side, you've got no x's involved. Okay. Again, this is just a number. Okay. It is an irrational number. Okay. Because this is going to end up giving us a decimal that does not repeat or stop. Okay. So remember the directions said if you got a funky looking answer, we needed the exact answer, which is going to be this. And then we also needed the decimal approximation. So let's go ahead and plug this into the calculator to get a decimal approximation. Be careful here, especially if you have an older calculator. You are going to do 1 divided by. The entire denominator would have to be in parentheses if you have an older calculator. Okay, so this is going to be e squared minus 1 close parentheses. Okay, if you don't put the whole denominator in parentheses, it will just take the 1, divide by e squared, get that result, and subtract 1, and that's not what you want. Okay, so the decimal approximation is very tiny. We're going to round it to 3 places after the decimal. So we're going to round it to 1.15. The 6, there's a 5 after the 6, so it will round up to 7. Okay, so we're going to say this is approximately 0.157. Okay. All right, and that is our decimal approximation. All right, so again, you need to check the answer just to make sure that this quantity does not cause you to take the logarithm of 0 or of a negative number if you plug it back into the original. Okay, so again, we're not checking for accuracy. So remember, x is about 0.157, so it's a tiny positive number. Okay. So if we go back to the original equation over here, okay, plug it in. 0.157 plus 1, that is going to be a positive number. So you're going to be able to take the logarithm of it. So that's okay. And then if you plugged in 0.157 here, you're taking the logarithm of a positive number, so it's going to be okay. Okay, so it works out. Okay, so this is the solution to your equation. All right, so let's take a look at the next one. All right, so here's part D. Okay, we've got the same situation that we just encountered. Okay, we have a logarithm minus a logarithm equal to a number. Okay, these are both base 4 logarithms, so we can combine them into one. Okay, using the same property we just used on example C. Okay, so again, if we are subtracting 2 logarithms of the same base, we can condense them into one logarithm. Subtraction will turn into division. Okay, so let's go ahead and try that here. Okay, so on the left side, we're going to make this one base 4 logarithm. Okay, so this will turn into division. This will become the numerator. This will be the denominator. So we will get log base 4 of x squared minus 9 over x plus 3 is equal to 3. Okay, and now we're in great shape because we have a logarithm equal to a number. Okay, once you have a logarithm equal to a number, you can do the arrow thing. Okay, so this is going to tell us that 4 cubed is equal to this fraction. Okay, so we will write that in the next step. Okay, 4 cubed is equal to this fraction. Okay, so we got that. All right, so 4 cubed, that's 4 times 4 times 4. That is going to give us 64. So I'll write it under here. All right, and so again, we have another fraction, looks a little intimidating. Okay, so let's go over here to get some more room. Okay, not sure if you see this or not, but what's going to happen here is that the top is going to factor here. Okay, so the left side is going to stay 64. The numerator here of this fraction actually factors. Okay, so just stick with me if you're not sure about this. Okay, here, let me get my ruler here and draw a little partition so we don't run into the other problems of work. Okay, so hang tight. I'll show you what's going on with this one. All right, so I'm trying to factor the numerator here, okay? So x squared is going to break down into x times x, and then 9 is going to break down into 3 and 3, okay? This is actually a difference of squares, okay? The square root of x squared is x, and the square root of 9 is 3, okay? So I've got that written down. You're subtracting, that's what difference means. So if you're factoring a difference of squares, you take the square root of each side and put, like, you know, them in the appropriate place like we just did. And the rule is the signs are one of each. Okay, so you put a plus or a minus. If you were to check this and FOIL it back out, you're going to get x squared plus 3x and then a minus 3x. Those would cancel, and then you would get the minus 9. So that is exactly the numerator here. Okay, the denominator is x plus 3. Okay, and why factoring the numerator was so useful is because now I have an x plus 3 in the top and 1 in the bottom. They cancel, and so I'm left with 64 equals x minus 3. Okay, so if I want x, I just add 3 to both sides. Okay, and I get that x is equal to 67. Okay, so that is the solution to my problem. Okay, all right, so we need to go check it to make sure that this actually works. Okay, so let's check it out. So I'm gonna go here. Okay, again, I'm not worried about accuracy. I'm just worried about, you know, if I plug in 67, is it going to cause me to take the logarithm of a negative number or a 0? All right, 67 squared is going to be a huge positive number. Let's see what it even is. 67 squared is going to give us, oops, 4,489. And so if I subtract 9, okay, I'd be taking the log base 4 of this number, and that's fine. You're taking the logarithm of a positive number. Okay, that's all we're trying to make sure we're doing. And then over here, if you plugged in 67 as the answer, you'd be taking the log base 4 of 70. So that's fine. We're taking the logarithm of something positive. Okay, so this is a viable solution. Okay, so that's the answer to part D.